Good morning, I'm Mr. Precella with my Math 1325 class, my face-to-face 1325 class, not my online class. And today we're going to discuss derivatives of E and Ln, and that means we're going to have some new derivative formulas. They're not that bad. And I was thinking about it. I think this is the last, these are the last derivative formulas you're going to get. So here we go. First of all, I'm going to differentiate the natural exponential function. Just remember, I'm starting with the derivative of e to the x, the natural exponential. That's called the natural exponential. And I know y'all have worked with e to the x in other math classes. And e is just an irrational number, approximately 2.718. We have two derivative formulas we're going to commit to memory. First of all, the derivative with respect to x just of e to the x. The derivative of e to the x, that's the easiest function there is to differentiate. The derivative of e to the x is just e to the x. And if we want to generalize this, suppose that the exponent is anything other than just an x. If it's anything other than just an x, the derivative of e to the f of x. We can differentiate this using that chain rule that we saw a couple of weeks ago. Remember, the chain rule says to differentiate a composition of functions, you differentiate the outer function first, leaving the inside function alone. So the derivative of e to a quantity is e to that quantity. So we have e to the f of x. But according to the chain rule, you then need to multiply by the derivative of the inside quantity. So you then have to multiply by the derivative of the inner function, which is f of x. So you then multiply by f prime of x. If the exponent is just an x and nothing else, just e to a single letter, the derivative is e to that single letter. If it's e to anything other than just a single letter, if it's a function of x, it's e to that function of x times the derivative of the exponent. And to illustrate that, I have some examples. I printed out problems from my math lab, and okay, here's the first one, and the instructions are just to find the derivative. The function we're differentiating is e to the negative 17x. Well, our exponent is something other than just a single x. So recall our derivative formula. If you're differentiating e to a function of x, it's e to that power times the derivative. Don't make these e's more difficult than they are. So differentiating this function, I'll just use the y prime notation. Y prime is equal to, it's e to a power, so the derivative is e to that power, times, now you differentiate that exponent. What's the derivative of negative 17x? Just negative 17, so I'll say times a negative 17, and we can clean that up a little bit to get y prime equals, I'd put the negative 17 in front of the e to the negative 17x. After we do a few examples, I'll stop and type in these answers into my math lab to show you how you input them. Any questions there? The derivative of e to the power is just e to the power. On number 2, Here's the second one I want to do. And if y'all are sitting out there, this number 2 is like y'all's number 2 in your homework, okay? If you're just watching me and you're not in this class right now, then that may or may not be like the number 2 in your homework. I remember a couple of years ago I had a class, I never really thought about this, but I had a class when they ran into stuff like this, they wanted to use the product rule. It was 5 times e to the negative 2x. And people just repeatedly wanted to use that product rule. That's not necessary if the e function, the natural exponent function, is being multiplied just by a number. If you're using the product rule, don't write this down, but the way they would do it, they'd say, okay, the derivative of 5 is, the derivative of a number by itself is 0, and then they'd say the derivative of e to the negative 2x is e to the negative 2x times the derivative of that exponent, which is negative 2, okay. And then they'd go, the derivative of the first times the second. 0 times e to the negative 2x is always going to be 0. If your factor is just a constant, there's no need for you to use the product rule. Just carry that constant down. In a moment, we'll have something like a 5x times e to the negative 2x. In that event, you have to use the product rule. But if it's just a number times e to the power, don't waste your time with the product rule. Here we go. You bring down the constant 5. The derivative of e to the negative 2x, that's e to the negative 2x, times the derivative of that exponent, which is negative 2. We're using this derivative rule right here. Let me move all of that up. We're using the fact that the derivative of e to the f of x is e to the f of x times the derivative of the exponent. And we can clean that up a little bit. 5 times e to the negative 2x times a negative 2. You can multiply those constant factors to get a derivative of negative 10 e to the negative 2x. Any questions there?
Yeah. Why is the derivative of 5e just 0 instead of 5?
Well, wait a minute. The derivative of a number, what's the derivative of a number?
Oh, I thought you were taking it of 5e.
No, I know. I'm taking the derivative of e to the negative 2x.
Right, cool.
The derivative of 5 times that is 5 times the derivative of e to the negative 2x. Any other questions? Number 3. Same instructions, just find the derivative. In this case, it's y equals e to the x cubed, differentiating the derivative of e to a function of x is e to that function of x times the derivative of the exponent. So it's e to the x cubed times, now we need to differentiate that exponent. What's the derivative of x cubed? 3x squared. That 3x squared is what we got when we differentiated x cubed. And we can clean that up a little bit and write the 3x squared first. It looks a little better if we write it like that. Question.
How do you enter in e to the exponent of x cubed?
You have to keep hitting either the shift up arrow, the little shortcut, or
Oh, okay.
Well, I'll punch that in a moment after we've done a few more examples, okay, to show y'all. I'll be typing in these answers in a moment for those of you out there wondering how do we type this in. But you have to enter the E you just typed from your keyboard, and then your exponent key to activate that, type the x, and then you have to activate the exponent again to type that cube. Number 5. This is like your number 5 if you're sitting out there this semester in this class. I can't say for sure that this will be like the number 5 next semester, but right now it's like your number 5. This problem's considerably more involved than the others. We have a product here. We have a product of x. We have x to the 5th times e to the negative 3x. In this case, you're going to have to use the product rule. Now, if that factor is just a number, you don't have to use the product rule. Just bring the number down. But this isn't a constant factor. It's a function of x, so we're going to have to use the product rule. That means I'm going to break it up as x to the 5th times e to the negative 3x. We differentiate x to the 5th. We know how to find that derivative. What's the derivative of x to the 5th? 5x to the 4th, I agree. Now let's differentiate e to the negative 3x. The derivative of e to the negative 3x is the derivative of e to the power is e to the power times the derivative of the exponent. So it's e to the power times negative 3. The derivative of negative 3x is just a negative 3. So I'm going to write it as negative 3e to the negative 3x. And now using the product rule, here we go. Y prime equals, it's the derivative of the first times the second, e to the negative 3x, sine plus the derivative of the second, that negative 3, e to the negative 3x times the first, x to the 5th. So here's what we have. We have, at this point, we have 5x to the 4th, e to the negative 3x, and that's going to be a minus, I multiply the negative 3 and the x to the 5th to write that as a minus 3 x to the 5th, e to the negative 3x. Starting the next homework assignment, we're going to be needing to ask ourselves, when is the derivative equal to 0? When is the derivative undefined? So, if you have a derivative that can be factored easily, then I recommend you start trying to factor it. My math lab would accept this as an answer, okay? But I'm going to factor it. I see a common factor. Both terms have common factors of x, and that both terms have common factors involving that e. So I'm going to take out a common factor. How many x's can I take out of the two terms? 4, the smaller power, and I'll take out that e to the negative 3x. With that in mind, what am I going to have left inside the parentheses? Okay, the first term, I took out everything except that 5, so I have a 5 minus the second term. I have 3 remaining. And I started with 5 x's, I took out 4, so I have 1 x remaining. My math lab would accept either of those answers. Any questions there? Let's do one more problem involving e, and then we'll stop and type in the answers. Okay. We have the binomial 9x squared minus 2x being multiplied by the natural exponential e to the negative 8x. What's the primary derivative rule we're going to have to use here? The product rule, because we have a product. I agree. We're going to need to use the product rule, just like that last one. And that means we need to know it's 9x squared minus 2x times e to the negative 8x. So we need the derivative of 9x squared minus 2x. What's that derivative? 18x. Keep going. Minus 2. Okay. What about the derivative of e to the negative 8x? Negative 8, e. Anything else?
Would it be negative 9x?
No, I don't think so. No. The derivative of e to power. Y'all are trying to mix derivative rules. Okay. The derivative of e to power is e to the power. Does that exponent change on x? No, that exponent does not change. When I saw that exponent was a negative 8x, that's the only thing you can have as an exponent on e. Is that exponent negative 8x. You then multiply by the derivative of the exponent, and the derivative of the exponent is just negative 8. I agree. Any questions there? Just like in the previous problem, where we had that, what was it? E to the negative 3x was e to that power, and the exponent on the e was a negative 3x. And notice, the only exponent we could have on e in our answers was negative 3x. So, e to the negative 3x, then you multiply by the derivative of negative 3x, which is just negative 3. Same thing's happening here. E to the negative 8x. The derivative is e to the negative 8x times the derivative of negative 8x is just a negative 8. And now we can use our product rule. It's the derivative of the first, 18x minus 2, times what? Okay, e to the negative 8x sine plus the derivative of the second, that negative 8 e to the negative 8x times the 9x squared minus 2x the derivative of the first times the second plus the derivative of the second times the first. And I see one glaring common factor. The terms are separated by that plus sign from the product rule. There's one common factor to both of those terms. What is it? There's one common factor. I couldn't hear you. E to the negative 8x. Yeah, it's e to the negative 8x. So I'm going to factor out an e to the negative 8x from both of those. Taking out the e to the negative 8x on the first term, what am I going to be left with here? 18x minus 2, I agree. We took out the e to the negative 8x, we're left with 18x minus 2. Here we took out the e to the negative 8x. We're left with a minus 8 times the 9x squared minus 2x. So that's an e to the negative 8x. We have an 18x minus 2. Distribute the negative 8 over the 9x squared minus 2x. Are y'all following me there? That's going to give me a minus 72 x squared, I agree, and plus 16x. So, combining like terms inside those brackets, I think I'll write this first. I'm going to write this in front of the e. The stuff just looks better if you have polynomial factors in front of the natural exponential. So we have a negative 72x squared. Combining the x terms, we get 18x plus 16x. That's giving me, is that 34x? 18x plus 16x gives me the 34x, and I have that minus 2 times e to the negative 8x. I suppose we could factor out a common factor of 2 here, but I think it would look better like this. I think it looks better like that. Any questions there? If you're using the product rule with e to the natural exponential e to something, then you're going to pick up that e to the something as a common factor that you can take out. Any questions? Let's stop recording for a moment and punch in these answers. Okay, so I'm signing off for a moment. Bye-bye.